Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and in this lesson what I'm going to do is I'm going to take the exercise that I asked you to do previously, which was the Christmas light sequences, and I'm just going to show you one example of how we could complete that program. Now, the first thing that I'm going to do is I'm going to go into the user.c file and I'm going to make sure that my ports are set up correctly. We have tris B, which is obviously the setup for port B, set up to all outputs with all 00. So that's perfectly fine. But what we do need to do is we need to be able to use the bottom or the lowest two bits, the two least significant bits of port A as inputs. So at the very least, I need those two least significant bits to be set up as inputs. So that's what I'm going to do now. So tris A. Now, in effect, what we want is the following. Okay, so the bottom two bits are set to 1. To do that, we would set to 0x03. Okay, and because that's the hex equivalent of that binary number that we have there, and that will set it up as the two least significant bits as input. So I'll just write that. Okay. Now into my main function here. Now I've already started with having a few bits correctly, and just before I continue, I noticed that since I set up this new project, I have it on the wrong compiler, so I just want to make sure I put it on the correct one here. So the XC8, and I also just want to check that I've set it up for the 16F88, which I think I've probably forgotten to do. And I have indeed. You can see this is set up for the 16F54, so I want to change that to 88. Careful when you're doing that you don't set it to one of the others, because you may find that some of the others do not have the correct settings. They may not have the same ports and so on. So we'll just apply that before I continue. And click OK. Now, so what I've done is I have some of the previous functions in here, such as the chase3 sequence, which I showed you previously, is there as a function. I have it down here, and I've shown you in a previous video how to do that, so I'm not going to redo that. But what I do want to do is I just want to set up chase3 as a function prototype up here, because if I put my function after main, it means I must have a version of that, or the prototype, just the top line of that with a semicolon after it, up above main, so that when main comes across it, it recognizes it. Now what I'm going to do is, because obviously we've got several different sequences that we want to cover here, I'm going to make the other sequences now. So it's chase 0, okay, so they're each of the different functions that we're going to use, and what we'll do is we'll copy and paste these from here down below, and then open braces and so on, so that we can complete them. So I'll just leave them here, and for each one of these I want to open a brace. It's made a closing brace for me, which is good of it. Again. Okay, so there are 3 chase sequences. Now what I want to do next is I want to set up the while loop so that I can call each of these chase sequences. Okay, and I need to be able to use the value from port A in order to choose which one I'm going to do. You could do this with a sequence of ifs and elses here, but I'm actually going to use the switch statement, which is just a shortened version of the ifs and elses. Hopefully you've all seen this before. So I'm going to say switch port A. Now you might wonder, should I put port A, the value from port A, into a variable? In this case, it's not particularly an issue because we're not actually modifying the value of port A, we're just reading in from it, so it's pretty okay in this particular case. Now, so case 0, in other words, if port A happens to be a value 0, I want to call the chase 0 function. And then I want to do a break. Now you'll notice that it indents my code nicely there. As soon as it realizes another case, it pops it to the correct place. So try and keep to that. Try and keep your code nice and neat, because it does make a difference. And also in any assessments that I do actually mark how neat your code is. So it's worthwhile getting in the practice of actually doing it now. So again, we go case 2, and you'll spot as soon as I put the colon here, it'll immediately put it back a tab to make it neat. So I'll just so that just speeds this up a little bit. Okay, so we need to make sure our switch statement closes, so it's got a closing brace, as we can see just there, and you can see the two have been highlighted in yellow so that we can see them. Then you can see my while loop is highlighted, both of those, and then this one, we can't see the top one, but that's the end of main. Okay, so what's going to happen in my main file is that each time I go through the while loop, I'm going to check what the current value of port A is, and whichever one of these values it happens to be, I'm going to call that function. I'm going to complete that function, come back out of it, which will bring you to the next line. It'll then bring you back out of the switch statement. We'll go around the while loop again, and we'll come back to this point where we'll check port A again at that point. Okay, so what we'll do is we'll just complete the chase sequences. So chase 0, what I wanted you to do was to put out to port B, I wanted you to put out the value 0xFF, in other words, put them all to 1. Chase 1 is not much more difficult. It's just putting out two sequences. Basically, put them out as zeros, then put them out as 1. This would cause the lights to flash on and off. Now, it should be pointed out that what I'm assuming in this case is that as you can see there from chase 0, the idea there of putting them all to Fs is that it would switch all of the lights on. And that's assuming that sending a 1 to the port would actually switch a light on. That may or may not be the case depending on the circuit that's set up for it. In fact, in many circuits, probably the majority of circuits, it's actually a 0 that would switch a light on. But for the moment, because we don't actually have any LEDs or anything like that actually attached to it, it's easier to think of the 1 as being switched on and the 0 as being switched off. So this is switching them all on here. Putting in a delay. Okay, so that's the chase 2 function. I'm just going to put spaces between these to neaten them up a bit. And or sorry, that's the chase 1 sequence. So the chase 2 sequence then, quite similar to the chase 3 sequence, except that we're only going up the way. So it's basically a shortened version of it. Again, I'm going to use the static keyword. Okay, so what I'm checking for here is I'm checking to see that has the value that we're putting out, has it gone to 8.0? In other words, has it reached the end? If it has, I want to set store to 0x01 to put it back to the beginning. And I want to put an else on this. So other than that, what I wanted to do is I wanted to shift up the way by 1 each time. Okay. And I'm noticing a lot of exclamation marks here, so I think I've made a little mistake here in this first case. And we noticed that a huge amount of them go away with that, so that solved that problem. We still have these exclamation marks pop up beside the delay function. Don't worry too much about that. I'm not entirely certain why they pop up, but it's fine. It still works perfectly. So these are each of my different chase sequences, as we can see there. And what I'm going to do is I'm going to run the project at that, see if I have anything else that I need to put in, and see how well it's going. Okay, so I've started running there. We can see that my inputs here, RA0 and RA1, they are both set to 0. Because they're both set to 0, I'm running the very first sequence, which is that all of the lights are switched on there, as we can see. Now, what happens if I switch to a 1 here? I should go to the next sequence, which is then flashing. And we can see them flashing on and off there. Okay. Now, the next sequence then is to check what happens if we've got 1, 0 written there, which means that we're going up through the sequence there. Okay. Now, as it's going up, I'm going to change to the next sequence, and we've swapped to it there, and we're going back again. Okay. Now, what we notice here, and I'll just show you one more time. So I'll set that to 1 so that we can see it. It's now on the chase 2 sequence, and it's going up cycling through it. If I change in the middle of that back to 0, 0, you can see that I immediately make a change. I don't have to get right to the end of it. Now, you may find that in some of the ways that you can write this program, that it may have to get fully to the end of the sequence before it changes over. Now, the reason that it's not happening in this version is that, and I just hit stop there, is that because both chase 2 and chase 3, only in those functions, they only make one movement of the port pins. They only make one movement of the lights before they go back to the main while loop. Okay, to follow the sequence. And that means that they check the new value of port A for every movement of the light in the sequence. There are other ways you can write it, and I'm going to do a short video to show you a method that I've seen some students use, where they put a for loop in there into the chase 2 and chase 3 sequences, which means that the full sequence is done inside the function before you return. That's perfectly fine, but as we can see in this particular situation, it leads to a slight disadvantage in that if you make a change, it takes quite some time before that change actually takes effect, which may be a good thing or a bad thing depending on what way you actually want to design the system. Okay, so that's one version of the Christmas lights to start off with.